expression for equivalent resistance when the wire is stretched. Either the length is increased by n times or the radius of the wire is reduced by 1 by n times. We know R equals rho times L by A. The resistance of the wire equals specific resistance multiplies length divided by area of cross section. The specific resistance of the material is constant, but the resistance of the material changes with length. As you increase the length, the resistance of the material increases. When you decrease the area of cross section of the material, then the resistance will increase. So let us go for the subject. After stretching the wire, if the length is increased by n times, then the resistance will increases by n square times. The final resistance R2 equals n square times the initial resistance R1. The specific resistance of the material is constant. So rho 2, the specific resistance after stretching equals the specific resistance before stretching. Let us replace the specific resistance by R times A by L on either side. Good. So let us multiply the left hand side and divide by L2. Similarly, on the right hand side, we multiply and divide by L1. And we know that A to L2 equals A1 L1, which is equal to the volume of the wire, which is same before and after stretching. We consider the volume doesn't change, the density doesn't change. So R2 multiplies V2 by L2 square equals R1 multiplies V by L1 square. V on either side cancels. R2 equals R1 times L2 square by L1 square, but we replace L2 as N1 times L1. On the numerator and denominator, this L1 square cancel. We get the final equation R2 equals N square R1. After stretching the wire, if the radius of the wire is reduced by 1 by n times, then the area of cross section decreases by 1 by n square times. So the resistance becomes n power 4 times. Then R2 equals n power 4 times R1. In the same way we work. Rho 2 equals rho 1. We replace rho 2 by R2 A2 by L2. We replace rho 1 by R1 A1 divided by L1. Now, the left hand side is multiplied and divided by A2. The right hand side is multiplied and divided by A1. So, on either side in the denominator, we get L2 A2 equals L1 A1, which is equal to the volume of the material that doesn't change because of the stretching. R2 A2 square divided by V equals R1 A1 square divided by V. V on either side cancel. So we get R2 A2 square equals R1 A1 square. Let us replace the area by R square. A2 is pi R2 square, A1 equals pi R1 square. Pi on either side cancels. So R2 is the resistance, small r2 is the radius. We replace the radius R2 equals to R1 by N1 because the radius is decreases by 1 by n times. R1 on either side cancels. Final expression R2 equals n power 4 times R1. Thank you, children.